Okay, so we are going to go over sections 2.1, 2.2, and 2.3 from your workbook. And just like in the previous video, I'm going to be working problems directly from the workbook. And as I mentioned previously, I'm going to do about a few problems from each section to give you a model of how you should solve the problems in each particular section. But please do go ahead and practice on your own the other questions also out of each section. So let's begin. So let's see. So 2.1, 2.2, and 2.3. Starting with 2.1. Suppose we want to determine whether a number is a solution of a given equation. So suppose we have the equation 7x minus 5 equals 4x plus 10. And we're giving the number x equals 5. And we want to see if this number 5 is a solution to this equation. So what we're going to do is we're going to plug in the number, right? 7 times 5 minus 5 equals 4 times 5 plus 10, and see if the equation is true, meaning the right side and the left side must equal. So 7 times 5 equals 35 minus 5 equals 4 times 5 equals 20 plus 10. So 35 minus 5 equals 30, and 20 plus 10 equals 30. So we can see that this is indeed the solution. So this does work, right? And so the answer is yes, this is a solution. Okay. Okay, let's see. Let's consider now, suppose we want to solve the following equation. So here we just need to solve. We have x plus 8 equals 11. So we have x plus 8 equals 11. And we want to solve this equation. Remember that whenever you're solving an equation, you're trying to find the value, just like in the previous example, that when you plug it in to the equation becomes a true statement. But in this example, we need to find the solution. The solution is not given to us. So what we're going to do is we're going to isolate the variable x. So we're going to get rid of this 8. And when I say get rid of it, we're not really getting rid of it. We're just going to move it to the other side, to the right side. So I'm going to subtract, because I have plus 8, I'm adding 8. So in order to move it to the right side, I'm going to subtract 8 from both sides. Now don't forget to do this on both sides of the equation, because you want to keep equality. So in order for us to keep equality, we must, whatever we do to the left, we must also do to the right, so that this equality symbol remains true. So plus 8 minus 8 is going to cancel, right? So that gives us x alone. So we bring down x equals 11 minus 8 equals 3. So here the solution is 3. Now you can check to see if the solution is true, is indeed the solution, by plugging it in. Plug in the 3 back into the equation as we did in the previous example, and then you can see if that works, correct? So you can do that also when you're practicing on your own. Okay, so let's try now a different problem. We're going to try something, let's try some fractions here. So suppose we have, I'm going to keep an eye on the screen to make sure that, that you can see the whole problem. X plus 8 over 9 equals 7 over 12. X plus 8 over 9 equals 7 over 12. So here we want to, again, solve this equation. So we want to solve. So we are going to move the 8 over 9 to the right by subtracting it from both sides, right? And so that's going to get rid of the 8 over 9s here, right? Or we can cross that out. And bring down the x equals, but now we have 7 over 12 minus 8 over 9, right? So we have a fraction now. And remember, we talked about subtracting fractions. We cannot subtract fractions that have different denominators, so we're going to need to find the least common denominator. And so when you look at 12 and 9, the smallest number that both of these numbers can go into with a remainder of 0 is 36, right? So we're going to need to change each fraction so that the denominators are the same. So we're going to multiply the first one by 3, right, to get the 36, and the second one by 4 to get 36. So this is going to be x equals 3 times 7 equals 21, 3 times 12 equals 36, minus 4 times 8 equals 32, and then 4 times 9 equals 36, right? Now we have the same denominator, which is, what we needed. So now we can write 21 minus 32 for the numerator and 36 for the denominator. And 21 minus 32 equals negative 11. And you can see that this is not going to reduce, right? Because 11 and 36 do not have any common factors. So that would be the answer here. X equals negative 11 over 36. Okay? So that is one. I wanted to consider this one because it has fractions. So we're going to deal with a lot of fractions in this course. And I know that some students don't like fractions very much, but usually it's because fractions were not taught properly in the earlier years of school, and the students are normally don't feel very confident when it comes to fractions. Okay, so hopefully we can change that in this course. So 2 over 3, let's solve. So we're more solving, equals p minus 5 over 4 plus 1/2. Okay. Now, instead of trying to combine these two fractions and then combine it with this other fraction, I'm going to combine it all at once. But in order to do that, I'm gonna need to move the fractions to the left, right? So that I can isolate the variable. So I'm going to add 5/4 to both sides, right? To move the negative 5/4 to the left. So I'm going to add 5/4. And so that's going to get rid of the 5/4. And I'm going to bring down the p plus 1/2. And then you bring down the 2/3 plus 5/4. And then I'm going to subtract 1/2 from both sides, right? And that's going to get rid of the 1/2. And so you bring down the p. And now you have 2/3 plus 5/4 minus 1/2. So all the fractions are in one side. And you can write, p equals 2/3 plus 5/4 minus 1/2, because it's always easier to read an equation where the variable is on the left side. We're used to seeing it this way and not this way, right? But it really does not matter. The answer will be the same. Okay, now you look at 3, 4, and 2, and you need to find the least common denominator, and we know that's going to be 12, right? So you're going to change each fraction so that you get the denominator that you need, right? Keep an eye on those signs, because sometimes, even the instructors, we make mistakes when we don't keep an eye on the signs. So 2/3, make sure you have everything, 5/4, and then the negative is there for the 1/2. So we're going to multiply this first fraction by 4, second fraction by 3, third fraction by 6. And so we get p equals 4 times 2, that's equal to 8 over 12, plus 3 times 5 is 15 over 12, right? Because 3 times 4 equals 12. And 6 times 1 is 6, but you have the negative, so it's going to be negative 6 over 12. And then you can write 8 plus 15 minus 6 all over 12. And so when you have 8 plus 15 minus 6, that gives you 8 plus 15. It's going to be 23, right? And then minus 6 is going to give us 17. So you get 17 over 12 as the answer. Okay? And so that's how you solve an equation that has more than, here we consider 3 fractions. Okay? And so that's section 2.1. So I wanted to cover a few problems from 2.1. Now we're going to move on to 2.2. So this was 2.1. Now moving on to 2.2. So let's see, 2.2. Again, it's going to deal with solving equations. So let's see. So more of that. So we're going to solve w over 5 equals 1.1. Well, this one, again, you want to isolate your variable. And so in order to do that, you need to, since I'm dividing by 5, I'm going to multiply both sides by 5, right? But this is going to be both sides of the equation. So I'm going to multiply both sides of the equation by 5. And so that's going to get rid of the 5 here on the left side. So w is equal to 5.5, right? 1.1 times 5, that's going to be 5.5. So that was pretty straightforward on how to answer that. And let's see, we're going to consider a little bit more difficult problems. Not, I wouldn't call them difficult, but just a few more steps involved. So suppose we want to solve negative 3x plus 8 equals negative 15. Okay? So you want to get rid of, you want to isolate the x, right? But here you can't, you should not, and you can't divide by negative 3 yet until you get rid of this 8. So you need to move 8 to the right. In order to do that, you're going to subtract 8 from both sides, right? And so that's going to get rid of the 8. So you're going to bring down the negative 3x equals negative 15 minus 8 equals negative 23, right? Now, when you get to this point, you should not forget that you have two negatives here, right? And so you want to isolate the x. And in order to do that, you're going to divide because you're multiplying by negative 3. So you're going to divide by negative 3, both sides. Remember that, well, the negative 3 divided by negative 3 is equal to 1, so that's going to get rid of those two. So that's going to give us x equals a negative divided by a negative becomes a positive, and so we have 23 divided by 3 as the answer, which cannot be reduced. Okay? All right. Let's see. Let's try to solve 7x minus 3 equals 5x. Now we have x on both sides of the equation. So remember, you want to isolate x, but in this example you have x on both sides of the equation. So you need to move one of either the 7x or the 5x. It doesn't really matter which one you decide to move, but I prefer to keep the x positive. So I'm going to move the 5x. So I'm going to subtract 5x just to keep the x positive. Why? Because if I subtract 5x from 7x, that's going to give me 2x, instead of subtracting 7x from both sides, which will give me negative 2x. So 7x minus 5x is going to give me 2x. You bring down the negative 3. Don't forget to bring down the negative 3. 5x minus 5x equals 0, right? Now, you want to now move the negative 3 to the right. So I'm going to add 3 to both sides, which will get rid of the negative 3 here. Negative 3 plus 3 equals 0. Bring down the 2x, which will equal 3, right? And then the last step is to divide by 2. And so the answer is going to be 3/2. Okay? 3/2 as the answer. So that's 2.2. Let's do a few more problems out of 2.2 before we go to 2.3. 2.1, 2.2, and 2.3, they're all very similar. It's solving linear equations. So another problem here, let me try this one. We're going to solve negative 6 over 7x plus 36 equals 92 minus 2 over 7x. Again, remember, you have a lot of problems in the workbook, and I'm covering some from each section so that it gives you a model. You should try more, but of course you have your homework in MyLabs Plus, and so that's going to give you plenty of practice. So once the ideal way to do this is you want to watch the video, right? And before you, of course, go to the problems and the homework, you want to watch the video and practice on your own in the workbook, and then you go to the homework, and that will give you plenty of practice. Okay, so here we have 6 over 7x plus 36 equals 92 minus 2 over 7x. Okay, so again, we have an example where we want to we have x on both sides of the equation, so they need to be together. These, yeah, I'm either going to move the negative 6 over 7x to the right or move the negative 2 over 7x to the left. To keep the x positive, I'm going to move the negative 6 over 7x by adding 6 over 7x to both sides, which will get rid of the negative 6 over 7x on the left, bring down the 36, right? I'm going to write here on the left so I have more room. 36 equals, and then we have 92 minus 2 over 7x plus 6 over 7x. Okay, perfect. Now I can say, well, because I have the same denominator, I can write minus 2x plus 6x over 7, right? And when I do that, I can simplify. This allows me to simplify the fraction. So I want to immediately simplify this fraction. I have negative 2x plus 6x, so which I wrote here, negative 2x plus 6x is going to give me 4x, right? 4x, so it's going to be 92. Now the 92 is not over 7. That was by itself. So only the fractions are divided by 7, right? That's why they're fractions. So negative 2x plus 6x is going to give me plus 4x over 7, right? And then 36. And let me erase the paper a little bit. I'm sorry. So let me explain again. So negative 2x plus 6x, I combine them here because I'm going to simplify them. Negative 2x plus 6x over 7 gave me 4x over 7. And you still have the 92 here. So remember, you want to isolate the variable. So I'm going to subtract 92 from both sides, right? Which is going to get rid of the 92, right? And just make sure that you're writing every step, because if we don't write the steps, we may get confused in the process. So you get, now that this is gonna get rid of the 92s, right? So I'm gonna write here on the side. So what I have here is 36 minus 92, which is negative 56, right? Equals 4x divided by 7. All right. And so, very good. Now we're going to get rid of the 7 here. I could do this in one step, but I don't want to confuse you. So we're going to get rid of the 7 by multiplying both sides by 7. So 7 times negative 56. And then we have 4x divided by 7 times 7. So there's a faster way, but I don't want to take shortcuts. Not at this level. Meaning not so early in the semester. So okay, so this is going to get rid of the 7's, and so you have 4x. 7 times 56, so 7 times 56, and remember it's going to be negative, is going to be negative 392, right? Negative 392. And now when you divide by 4, because I'm going to get rid of this 4, right, is going to give me negative 98 as the answer. Okay, so that's negative 98 as the answer. Alright, so this one was a little bit longer, but you know, that's why I'm making these videos, so that you can watch them as many times as you need to, and then you can pause and write down, you know, and so hopefully it will help you. And yes, and I know it's gonna help, because it always helps to see how these problems are worked out. Let's do another one. Before we move on to 2.3, I want to work a divided by 2x equals 40 over 3. Okay, so let's see this one. This problem, I'm going to do this one, and then I'm going to do one that's in the homework, that's in the workbook, that's similar to this one. So let's do this one. I can tell you that the easiest way to do this is to move the 2x. I'm going to move the 2x to the top. So one quick way, I'm going to show you, one quick way to do this is to flip the fractions. 2x over 8, and this is allowed. I mean, I can show you the proof, but I don't think you want to see the proof. And then, but if you're doing, notice that instead of having 8 over 2x, I wrote 2x over 8. But I need to do the same thing to the right, so 3 over 40. So that way, that moves the variable to the numerator where I need it. And again, you know, I can prove this mathematically. I can do this. No, there's a proof for this. But for the sake of time, unless if you want to see this separately, just send me an email if you want to see the proof, and I can do that on a separate video. Okay, so now you want to get rid of the 8 here, right? So I'm going to multiply both sides of the equation by 8, right? And so the 8's will cancel here. And when you multiply by 8, when you have a fraction like this one here on the side, you're really multiplying by 8 over 1, right? So I'm going to show you here that you can, you know, you get rid of the 8, so you bring down the 2x equals, this one is like multiplying by 8 over 1, really. So you multiplied 8 times 3, right? Divided by 4 times 1. Or what you can do is the trick I showed you about reducing diagonally, where the 8 goes into 8 once and 8 goes into 45 times. That way you just have 3 times 1, which equals 3. 5 times 1 equals 5, which is a lot easier. Once again, the reduction, diagonal reduction, remember I showed you that on the previous video. 8 goes into 8 once, 8 goes into 45 times, and then you have 1 and 5 instead of 8 and 40. Then you can just multiply 3 times 1 and 5 times 1. Okay? Okay. Now, now you're going to get rid of this 2. So you're going to divide by 2. And when you do that, you just divide both sides by 2, divide by 2. And so you get rid of the 2's and you get x equals, you have 3/5 divided, I'm going to do divided because I'm dividing by 2, by 2. But because I'm dividing by 2, I can write divided by 2 over 1. Because I have a fraction, you want to make the second number, write it as a fraction. So write 2 over 1. And then remember that when you're dividing fractions, this division is going to change to multiplication, right? But you need to invert the second fraction, so this becomes 1/2. Instead of 2 over 1, you write 1 over 2. And so x is going to equal 3 times 1 equals 3. 5 times 2 equals 10. So this is 3/10. Okay? So this was an extra problem. This was not in the workbook. Now I'm going to do one similar that's in the workbook. This one in the workbook, we have 8 over 5x. And we have 0.45 divided by 14. Again, you're going to change, you're going to invert both fractions. So you're going to write 5x over 8 and 14 over 0.45, right? And you're going to multiply both sides by 8 to get rid of the 8's here. Bring down the 5x equals, and remember this is going to be 8 over 1. Now here I'm not going to be able to reduce, but I'm going to multiply directly. So 14 times 8. 14 times 8 gives us 112. 0.45 times 1 is 0.45, right? And then you're going to divide by 5. Both sides of the equation divide by 5. So that's going to get rid of the 5's here. And then you have x equals 112 divided by 0.45, and then that's going to be divided by 5. So this one, you can use a calculator. I'm going to show you here. 112, so you put the fraction, right? 112 divided by 0.45, right? Gives me 248.88. If you divide that by 5, it gives you 49.777. Now you can do it this way and then just round, or I can show you how to take it further by hand. We can do this by hand. So what I can do is 112 divided by 0.45. I can write 0.45 as a fraction instead of a decimal, right? I can do that, and I can write, this is going to be 45 divided by 100, right? And that divided by 5. This is going to be long, but I want to go through it so you can see. So this is 112, right? And I'm going to divide that by 45 over 100, and then I'm going to divide that by 5. So I'm going to take this one first. I'm going to work this one first. So x equals 112 over 1 times, I'm going to invert 100 over 45, and I'll do division by 5 last. This is going to be the last step. Okay? And so it's going to give you the same answer. So x is going to be 112 times 100. That's going to be 100. This is going to be 1,200 divided by 45, and then that divided by 5, right? And so let's see what that's going to give me. So 11,200 divided by 45 again, and then divided by 5. It gives you exactly the same answer. But you're going to need to round. So it gives us like 49.777 something. So we can round this to, let's round it to 49.8. Okay? We will just round it to that. And so whenever you're dealing with decimals, you don't need to do this by hand. Just use the calculator here whenever you have decimals, and then I'm going to tell you what to round to, so don't worry about that, because I know that sometimes, it can get, like, the numbers can get really crazy. So, but you're going to get the same. So if you stop here and use the calculator right here, if you stop here with the calculator, that still gives you 49.8 rounded to the nearest tenth. Or if you do this by hand, which I don't really recommend you go through all this, just use a calculator. At this point, just use a calculator. Okay? Alright, so that was section 2.2. And like I said, I'm going to try to make these videos not too long. So I want to do some problems from 2.3. And let's see, 2.3. So again, more solving equations. We have 3x minus 8 equals negative 4 times 2x plus 5 minus 3 times 4x minus 8. Okay? Alright. So the distributive property needs to be applied here, right? So let's get rid of these parentheses. So you're going to multiply every term inside the parentheses by negative 4 and every term inside this parentheses by negative 3. Negative 4 times 2x equals negative 8x. Negative 4 times 5 equals negative 20. Negative 3 times 4x equals negative 12x. Negative 3 times negative 8, positive 24. Bring down the 3x minus 8. And then combine like terms. So you have 8x, negative 12x. That's going to give us negative 20x, right? And negative 20 plus 24, that's going to give us plus 4. Okay, and then bring down 3x minus 8. Okay, and so I'm going to move, I'm going to move the negative 20x to the left so that I keep the x positive. So plus 20x, and that's going to give me 20x plus 3x is 23x. Bring down the negative 8. This is going to get rid of the negative 20x. You bring down the 4. And then I'm going to move the negative 8 to the right. So I'm going to add 8 to both sides. And so that's going to give me 23x. Gets rid of the negative 8 plus 8 equals 0. So just bring down the 23x equals 12. And then the last thing is you're going to divide by 23, right? Because you're multiplying by 23. Which gives us as an answer x equals 12 over 23. Okay? 12 over 23. All right. So that is how to solve equations, linear equations that have where we apply the distributive property. Now, an equation can have, the next topic deals with the types of situations you can encounter when you're solving linear equations. So an equation can have one solution. That's one case. Can have one solution. I should put two like this. No solution, or an infinite number of solutions. So 3 cases: one solution, no solution, or an infinite number of solutions. So for example, we're going to consider examples of each. So suppose we want to solve 6.3x minus 8x minus 10 equals 2.2x minus 5 times 2 minus 0.1x. Okay, so let me make sure that I have everything written there. 6.3x minus 8x minus 10 equals negative 2.2x minus 5 times 2 minus 0.1x. Okay, looks right. Okay, now you're going to combine like terms on the left side, right? So if you have 6.3, you have 6.3 minus 8. That's going to give you negative 1.7x. Bring down the negative 10 equals, and then you have 2.2x, and you need to get these terms out of the parentheses by multiplying by negative 5. So negative 5 times 2 equals negative 10, and negative 5 times negative 0.1. Now remember, a negative times a negative equals a positive, so it's going to give me plus, and so 5 times 0.1 is equal to 0.5. So it's going to be 0.5x, right? You can combine like terms. So you have 2.2 plus 0.5, which is 1.1. So you have 1.1x minus 10, negative 1.7x minus 10, right? And so you're going to now, you're going to move the 1.1x to the you're going to move it to, this was, 1 second, it was 9, it was a positive right here, yeah, and I'm just double checking something because this should be 0.5x. Okay, it looks right here on the side. I think I wrote it correctly. Okay, I was just double checking to make sure I wrote it correctly. Now I'm going to move 1.1x to the left, or I'm going to move negative 1.7x to the right. It looks like I want to move, I'm going to move the negative 1.7x to the right, so that for some reason, hold on a second, I think I keep seeing this problem as 6.3x minus 8x minus 10. Just give me 1 second. I just want to make sure I have. Oh, I see. Yeah, I caught the problem here. It's not a problem. It's just that this problem, this was supposed to be negative 2.2x, but I'm gonna solve it this way, and then I will solve it with the negative. Okay. So let me continue, but it is correct. So I'm gonna add 1.7x to both sides. 1.7x. And then that's going to get rid of the negative 1.7x, bring down the negative 10. And so 1.1x plus 1.7x is going to be 2.8x, right? 2.8x minus 10. And then I'm going to add 10 to both sides. We're going to add 10 to both sides. And that's going to get rid of the 10s on both sides here, right? So this is going to give me 0 here and 2.8x on this side. Once you have, so I'm going to write it here, I'm going to continue here. So we have 0 equals 2.8x divided by 2.8, both sides, will give me 0 equals x as the answer. Now, this is an example of one solution, right? Because I have one solution, x equals 0, and no other solution is going to work. So this one has one solution, right? So remember the 3 cases. We have one solution, no solution, or an infinite number of solutions. So this is an example of a one solution. Okay, now let's do an example of an infinite number of solutions. So there's the top, if you need to see it again, and there's the bottom. Okay, so this one has one solution. Now let's do an example where we have many solutions. So this same problem is going to be different if I write it like this. Look, I'm going to just change the sign. So 6.3x minus 8x minus 10 equals negative 2.2x minus 5 times 2 minus 0.1x. Notice I changed the sign of instead of 2.2 I wrote negative 2.2, and you're gonna see how that's gonna change everything. Okay, all right, so combine like terms again. You have 6.3, right, minus 8, and that's gonna give us a negative 1.7x right here when you combine these two. So bring down the negative 10 equals negative 2.2x. Again, negative 5 times 2. We need to get these terms out of the parentheses. So we're going to multiply each term inside the parentheses by a negative 5. So a negative 5 times 2 equals negative 10. A negative 5 times negative 0.1x is a positive 0.5, correct? 0.5x. And last time I wrote 0.5. They're both correct. Okay, now you have, let me bring down negative 1.7x minus 10 because I cannot combine these further, but I can combine the negative 2.2x and the 0.5x. A negative 2.2 minus 0.5 is going to give me, notice that when you have negative 2.2, right, and you add 0.5 is going to give you negative 1.7x minus 10. Now, I want you to see this. You have negative 1.7x minus 10 equals negative 1.7x minus 10. So you have the same thing here. You could stop here and say that you'll have an infinite number of solutions. Why? Because regardless of which value you pick for x, you have the same thing on the left side as you do on the right side. So those two sides will always be the same. It does not matter which x you pick. You pick x equals 1. On both sides, you're going to get the same thing on the left and on the right, meaning that the left and the right will be equal, meaning that the equation will be true, regardless of the x, correct? So here, at this point, we can stop and say that there's an infinite number of solutions. Once again, because it does not matter which value you choose for x, the left side will always be equal to the right side, right? Because you have exactly the same thing on both sides. So then we have an infinite number of solutions. So this is the second case, right? That where you have an infinite number of solutions. So we could continue, and I want to continue to show you what would happen if I continue solving. So you have negative 1.7x minus 10 equals negative 1.7x minus 10. What's going to happen? I'm going to add 1.7x to both sides to get rid of the negative 1.7x and move it to the right. By doing that, I'm going to get rid of the negative 1.7x on both sides. I'm going to bring down the negative 10 equals negative 10. So you have exactly, this is always true. So the same conclusion. This means that you have an infinite number of solutions. Same conclusion. Infinite number of solutions. Okay, so the last problem of 2.3 I'm going to consider is the following. You want to solve 4x plus 5 equals 3x plus 5. Okay, so I want to keep the x positive, and so I have x on both sides, right? So I'm going to move 3x. I'm going to subtract 3x from both sides to keep the x positive. Now 3x minus 3x, I get rid of that, bring down the 5. 4x minus 3x, you see how that is going to keep the x positive because 4x is bigger than negative 3x. So 4x minus 3x equals x. You don't write 1x, you just write x, and then bring down the 5, right? And now, then you're going to, so we have 4x plus 5 and 3x plus 5. Let me just double check to make sure. So you did minus 3x on both sides, bring down this 5 and then plus 5. And then we're going to subtract 5 from both sides, right? Minus 5 minus 5. And so that's going to give us x equals 0 as an answer. This is one solution. Okay, because it's one solution. So we consider the one solution and we consider the infinite number of solutions. You know, I have one more case that I need to consider because we haven't considered that, the no solution case. So let's do the one with a no solution case. So suppose we want to solve 7 times 3x minus 4 equals 21x minus 5. So first of all, I must multiply 3x minus 4 by 7 in order to get rid of these parentheses. So 7 times 3x is 21x. 7 times negative 4 is negative 28 equals 21x minus 5. And now we're going to add 28 to both sides. Why? I mean, you could have subtracted 21x. This is okay. At this point, you could have stopped because 21x minus 28 can never equal 21x minus 5. But I want to continue to show you what you're going to end up with. So you have 21x, right, equals 21x minus 5 plus 28. That's going to give you 23, right? And now, once you get rid of, you subtract 21x from both sides to get rid of the 21x. And that's going to give me 0 equals 23. And you know that this can never be true, so this is false. So this means that there is no solution. No solution here, because this is false. Okay? So we are at 41 minutes already. So I want to stop the video here. Like I said, you know, I don't like making the videos too long. I'm going to try to keep them under an hour. Sometimes I will need to make more than one video if the lessons are, because the lessons will become a little bit more complicated as we move forward in the course. But so when I see that, I may need to, instead of giving you one video over several sections, I may give you a video per section. So we will see. But this is the video for week 2. So remember, week 2, you have sections 2.1, 2.2, and 2.3, and keep track of what's due. You have a timeline. You have everything that you need in Canvas. So send me an email if you have a question, or if you would like to meet with me for tutoring, you can do that as well. Also remember that you have tutors in Math World. You just go into your Canvas course and click on the virtual Math World, and you have tutors, live tutors available at no charge to you. So take advantage of that. So okay, so this is it for today. That's it. I will see you. I will well, I can't really see you, but we will talk again in the next video. We will continue, I should say, in the next video. Take care. God bless you. Bye bye.